Now, effectively, all we've done in terms of our clone method is duplicated what's in the object class for cloning. And that constitutes what's called a shallow copy. That's probably not quite what we want, as we're going to see. In this slide, we discuss the distinction between a shallow copy and a deep copy. So take a look at this example here where house number 1 is a new house with ID 1 and square footage or area of 1750.50. If we want to clone house 2 as a clone of house 1, we could declare it to be of class house and say house 2 equals, and then we cast house 1 as a house and use the clone method with it, and we would get a clone. But let's take a closer look at what exactly the clone contains now. Well, in the case of the ID and the area, those are both primitives. One was an integer, one was a double, and we're going to actually get copies of those in memory, in separate areas of memory. So you can see that ID is copied into memory somewhere for house, and so is the area, and so is when built for that matter. But when we clone, we get a fresh piece of memory with a fresh value for ID1 and a fresh value for the area. Those two primitives now have their own place to live. Well, when built is actually a reference to an object because the date is an object. It's not a primitive. And if we look at the differences, what happened is that we got our own copy of the reference. That's true. So when built is a reference in two different areas of memory for house 1 and for house 2, but the problem is they are references. And as references, they point to the same date object, which means the date object itself did not actually get cloned. There's only one copy of it. So how can we really claim that house 2 is a clone of house 1 when it's actually sharing the exact same date as opposed to a clone of the date? The shallow term captures the fact that we haven't gone deep enough. We've got a shallow copy only. We've copied the reference to a new place, but it's still the same value of reference, and it still points to the same date object. We did not do a deep copy here. We've done rather a shallow copy. By comparison, this next slide captures what really should have happened. Here you can see that house 1 and house 2 live in distinct places in memory just like before, but now there are two distinct date objects, and one is referred to by when built in house 1, and the other date object is referred to by when built in house 2, and those two date objects are now distinct objects. This is called a deep copy, and it represents a proper cloning of our house object. So what we should do to provide a proper deep copy of our house class is we should go back and look at the code that we have written to override the clone method, and instead of just calling the super clone, we should still go ahead and call it, and at that point we're going to have just a shallow copy, but then we can turn around and say house clone dot when built equals Java util date, so we're casting when built dot clone as a date, and now we have a separate new date, and now we can return that final version of house as a clone, which will now be a proper deep copy. In this last slide we see an alternative implementation where we use a try catch block to do the same thing essentially.